The Manufacturing Engineering Department of the University of Nottingham is presenting a capability-based approach for reconfiguration, which is carried out by a multi-agent system. We have set up a modular production system to demonstrate plug-and-produce. We define plug-and-produce as a methodology for automatically managing the introduction and removal of assembly devices from an assembly system. This demonstrator has 8 independent workstations in terms of mechanical structure and electrical wiring. Each workstation is controlled by its own programmable logic controller, short PLC, which is located below the station. The PLCs host and run JADE agents and form a multi-agent system via the Ethernet network. Between the two robots is a shared tool-changing rack. It can hold up to 6 different multi-purpose tools for various assembly operations. Either robot can attach any tool in order to perform an assembly operation on the product. All parts needed to assemble the product are transported on a pallet. This pallet is delivered by a linear transport system. The last workstation is used to validate the assembly of the product. It consists of a camera and a mechanical test which can be unplugged independently from each other. The full automated assembly system has 2 separate human-machine interfaces, or short HMIs. This is the plug-and-produce HMI, which is an interface for managing plug-and-produce operations.
The product to be assembled and the test that needs to be performed on it was just selected. With this screen, the operator can check which devices are available. Red indicates which devices are missing to produce the chosen product. Green indicates that a device is plugged in, which is represented by an agent.
The operator follows the hint on the screen and plugs in a camera. An agent to represent the camera has been created on its PLC and registers on the main JADE container. The system aggregates existing capabilities from the agents and matches it against product requirements. Once the product can be assembled, the agent system is able to generate the allocation of tasks to download it to the PLCs. The carrier has been manually loaded with a new pallet. Here the product is a detent hinge which is used in commercial truck interior.
This is the second HMI which is used for operating the assembly platform. The placement of the pallet is confirmed and the assembly is started.
In our current design, the multi-agent system is only used for the reconfiguration of assembly systems. In particular, the multi-agent system has only control down to a certain level of abstraction, below which point the PLC is in control. We follow this design for 2 reasons. Firstly, PLCs are typically the product of many years of practical use and thorough testing in industry. Industrialists, especially those who are not familiar with agent technology, would only allow and trust their own PLC programs to control lower-level processes, for example to control a robot's movement.
Secondly, industrialists hesitate about giving third parties access to lower-level PLC control algorithms.
In this scenario, the robots are sharing the assembly tasks. The robot on the right has started the assembly, and the one on the left will finish the product.
The inspection station is configured to use the just plugged-in camera together with a mechanical test.
A device can be plugged out for various reasons. It can be an operator's decision to exclude a device from production, to maintain it or to use it somewhere else, or the device is removed due to a breakdown. In this scenario, a product and a test had been selected.
Now we are plugging out the robot on the right from the power supply and communication interface without any notification to the system. The agent representing the device disappears from the main container after unavailability.
The HMI presents the absent device with a red icon. The hint below doesn't change because it is still possible to produce the product with a second robot. As you can see, the overall configuration of the assembly line has now changed. The carrier doesn't stop at the first robot, but travels directly to the second robot.
The configuration of the robot has changed to a different task sequence.